my name is Christy, and I am a broadcast science teaching major over at Edgewood College. I'm doing this project as part of my tech literacy class for my education minor, and what I'm doing here is showing how we can use laptops and other equipment to record certain things that can be used to be put up on the internet or be used in class during science labs or science classrooms for part of our demonstrations or experiments that might be done during class time, or even if there's no time to do an actual experiment in class, you can simply just show a video and your students will hopefully be able to understand what's going on. This is Leto. He's with me because he's kind of a little bit of a pest and can get grumpy when left alone, and I'd rather not have him be making background noises excluding what he is doing right now. So this first experiment I have right here is the basic idea of having a volcano erupt, where almost every single science student that has gone through elementary school has seen the classic baking soda and vinegar experiment. Now this is the same kind of thing, only instead of kind of showing it coming out of a volcano, a model volcano, this is showing how it will basically just erupt into like an ice kind of volcano. So everything here is white, and an idea for icy volcanoes is that they do exist on, I believe it is Titan or Io, and so even though we have classic ideas for volcanoes, there are still other kind of volcanoes that we need to consider teaching our own students about. So here's the basic experiment. Vinegar, water, and baking soda are already all been pre-mixed. And I added glitter to this because the recipe I found is basically saying that when you do all of this, you can make it into like a fun kind of stuff for kids, students, and so this is kind of like all fine stuff. It's been poured into cornstarch, which can be used to make little fake snowballs. And where I originally found this idea was on something that said that after you have your volcano erupt, you can basically just start pouring in Lego characters and have all this fun stuff. And so this is a nice, pretty, I added glitter, I think I said that. But you got your basic idea here for how a volcano erupts. I'm going to let this mix this in a little bit. See, sometimes Leto actually tends to kind of get upset when he sees things happen that he doesn't expect, but he actually is very good about this right now, so I'm guessing that I can take this as something I could actually have him in the classroom for, because I'd like to use him as a technology tool, well, educational tool in my own classroom. So here, it's almost like even looks like that fun experiment where you work with if it's a solid or a liquid. Now the next experiment I have here is actually something that's going to take a bit of time, and so I'm actually going to do it as my second of 5 experiments, simply for the fact that it's supposed to take some time. And it is right here, set up right here. It's an idea of a volcanic eruption. So what happens when a volcano erupts is that it basically just, stuff will come out of the ground. And so right here I got a thing of sand and water. I also have a hidden ingredient in here that is actually going to show what happens when a volcano erupts. But for that to actually start happening, I need to turn on the heat, which is why, since it's going to take some time, it needs to be done very slowly. So I'm going to just have this in the background as we move on to our other experiments. So like I'm saying, that most students had this stereotypical idea of what a volcano is, where it's just a big cone where lava flows out and it's big and explosive. But what I'm showing here is going to show how to actually build a shield volcano, which is the non-stereotypical type of volcano. It's the volcanoes that you will find in Hawaii, or even these are the kind of volcanoes that erupted that caused the Permian mass extinction. So again, it's kind of like a volcano that this is just a base, and the experiment is simply just setting up, creating a model for a volcano. So I got right here, this film canister is what's going to be the actual magma chamber where magma is going to be pouring out of. Then I got some newspaper balls that I'm just going to attach to the base. Now that I got the newspaper attached, and I got the film canister, the magma chamber in the center, I'm going to tape down some foil, and we will have here a perfect little volcano. Well, not entirely perfect, but an idea. You can see here that trying to make it look not like cone, but more like a shield. And so it's kind of just a little bit rounded, and I gotta find the film canister. Poke a hole in. And here you have your little model of a shield volcano. Now, if I were doing this in the classroom, I possibly would have some glue or something, and we could put some sand on it, or just make it look, you know, a bit more realistic. This is just supposed to be a model. It's not supposed to be the actual volcano, so that's what I'm doing here. Now we're going to make the lava to go into the volcano. Now see, this was made from materials that are already all laid out, and so I didn't exactly have to explain what I was doing. But here, this is to make the shield volcano lava. Now I got glue here. This equals about 1 cup of glue. This is a mixture of borax and warm water, and this is simply just water. Now this is about 3/4 cup water and 1½ teaspoons of borax. And to make this, I'm going to have to pour in a cup of glue. This is nice and warm. It could be hot. It cannot be cold. I do not know. And so I'm just going to add this. Mix the water and the glue together. I'm going to add the borax in the water. And it's already getting slightly gelatinous. Smells funky too, but I guess that's okay. It's very runny, and that's supposed to be what shield volcano lava is like. I think it's a thicker kind of lava, and it doesn't actually flow. Well, it will flow, but it won't flow very far, and that's why when you actually see shield volcanoes such as Kilauea, Mauna Kea, Mauna Loa out in Hawaii, you don't see the cone. You see basically this, you won't possibly, it's like, unless you're actually right on top of the volcano looking down, you won't even realize that you're on the volcano. See how it just very, very runny. And it still doesn't look like our little thing over here is warming up, so I'm going to turn up the heat just a little bit more. Shield volcano. Got the shield volcano here. This isn't the kind of lava that you would see like erupting out of one of the classic volcano experiments. And so I'm just going to have it be running down to show that as it's slightly moving, but it's moving very slowly. Get some of it into the film canister, and then the rest of it can just flow outwards. That was expected. that's actually something that reminds me of something where most of science is trying to explain what went wrong. Well, what went wrong there is that the glass that I was pretty sure was heat safe and could work for that experiment was obviously not. So, just have that volcano erupting right over here. And move on to the final, which is how does magma move in the earth? So right here I got this nice vase that I'm not going to put on a stove. It's full of water. This is nothing but water. Nothing's been added to it. I'm going to add some vegetable oil to the top. And wait for it to actually condense at the top. Add a little bit more. And this shows what happens with magma moving on in the earth. Is that, no, this is not edible, little bird. Is that what you have right here is basically what happens when magma reaches the surface. It just will go outwards. But how does the magma get to the surface? Now this is something that shows how a magma plume works. Magma plumes basically are what's at Hawaii, it's underneath Iceland, it's actually even in Yellowstone, is a magma plume. So, you see how that the salt takes the oil down, but then as soon as the oil reaches the bottom of the salt, it just comes right back up. This is kind of like what happens in a lava lamp. Just add salt in there. That the salt takes the oil down, the oil drops the salt at the bottom, and then makes its way back up. And the back up motion is basically how magma moves from the core, well not from around the core, to the surface of the planet and then erupts, which is happening right here now onto my kitchen counter. As my last experiment did not go very well. Thank you for watching. Everything else that went well.